Hello. Now, in this video, we're going to be looking at equilibrium in the market for goods and services. We're going to be extending the multiplier model to derive the IS curve. We need to start with a key result from a previous video. The short-run element of aggregate supply, what we know as the output gap, must be exactly equal to the short-run elements of aggregate demand, or the non-structural components of expenditures. That is, the sum of the non-structural components of consumption, investment, government, exports, minus imports. Note that we're expressing everything in percent of potential output. We already learned how to express this key result in a graph, the 45-degree line. On the horizontal axis, we have the output gap. On the vertical axis, we have the sum of the elements of non-structural expenditures, consumption, investment, government, exports, minus imports. You may remember that on a 45-degree line, the value on the horizontal axis is exactly equal to the value on the vertical axis. So suppose if we have an output gap of 0, that means that the sum of the non-structural expenditures on the vertical axis must be exactly 0. Alternatively, let's suppose that we have an output gap of 1%. That means that the sum of these non-structural elements to expenditures must also be 1%. Alternatively, let's suppose that we have a negative output gap, minus 1. That means that these non-structural elements must also sum to minus 1. Now let's recall the non-structural elements of expenditures: the cyclical component, the interest rate response, and the autonomous component. The cyclical component of non-structural expenditures are that portion of expenditures that are linked to the output gap: consumption and imports. If the output gap goes up, households have more income to spend, they consume more, but some of that extra consumption falls on goods that are produced outside the economy, imports. In the other direction, if the output gap goes down, household income goes down, they consume less, and they also reduce their expenditures on imports. The red line in this graph shows us the relationship between the output gap and the cyclical component of expenditures. Since these expenditures rise when the output gap rises, the line slopes upward. For example, we've assumed that the marginal propensity to consume is 0.3, the marginal propensity to import is 0.03, so the slope of this line has to be 0.3 minus 0.03, or 0.27. The slope of this line, positive 0.27. Now you remember from the multiplier model that equilibrium must take place where the 45-degree line and this expenditure line intersect one another. You should also recall that changes to expenditures that take place on an autonomous basis will be reflected in shifts in this line. For example, suppose that expenditures increase on an autonomous basis. Suppose that the government increases its expenditures, perhaps because it wants to stimulate activity. In this case, the line shifts up. The initial increase in government spending will bring about subsequent rounds of spending, what we might call ripple effects, by households and firms. As a result of these ripple effects, the new equilibrium output gap, as shown by point B, can increase by an amount that is greater than the initial expenditure shift itself. In the other direction, suppose that government expenditures decrease. Perhaps the government needs to tighten its belt. In this case, the red line shifts down. The initial decrease in government spending will again ripple through the economy, causing households to reduce their spending as well. In this case, the equilibrium output gap can fall by more than the initial expenditure shift itself, in this case falling from A to C. So now we'll examine the interest rate response, the remaining element of non-structural expenditures. We previously learned that if the interest rate goes up, current consumption becomes more expensive and capital costs more for firms. So, when interest rates rise, spending must fall. Households consume less and firms invest less. In the other direction, if the interest rate goes down, current consumption becomes cheaper for households and the cost of capital falls for firms. Hence, if the interest rate goes down, households consume more, firms invest more, there's more spending. We can show how changes in the interest rate can affect the output gap by extending our multiplier model. When the interest rate falls, expenditures will rise, as reflected in an upward shift of the red line, and the output gap goes from point A to point B. In the other direction, when the interest rate rises, expenditures fall, as reflected in a downward shift of the red line. In this case, the output gap moves from point A to point C. There's another way we can visualize the relationship between the interest rate and the output gap. In the graph to the right, the output gap is still on the horizontal axis, but now on the vertical axis we have the real interest rate. These same 3 points, A, B, and C, are shown here to lie on a downward sloping red line. Again, A is our initial point, where the output gap is 0. When the interest rate falls and expenditures rise, we move from point A to a point like B. Alternatively, when the interest rate rises, expenditures fall, we move up the line to a point like C. In fact, this downward sloping line tells us about the equilibrium relationship between the output gap and the interest rate in the market for goods and services. We call this line the IS curve. At any point along this line, aggregate demand exactly equals aggregate supply. Points that lie upward and to the right of this line represent cases where aggregate demand exceeds aggregate supply. Expenditure and output are too high for the given interest rate. In order to return to the line, expenditures have to fall and output has to fall. Points that lie downward and to the left of this line represent cases where aggregate supply exceeds aggregate demand. Expenditures and output are too low for a given interest rate. In order to return to the line, expenditures must rise, output must rise. We can easily incorporate autonomous changes to aggregate demand into our IS curve. For example, let's suppose that we have an autonomous increase in aggregate demand. Suppose that the government spends more. In this case, the red IS curve shifts to the right. Alternatively, let's suppose that we have an autonomous decrease in spending. For example, the government tightens its belt. In this case, the red downward sloping IS curve shifts to the left. Now, you may be asking, why is it called the IS curve? So let's take a simple example, a closed economy with no government. Output is equal to consumption plus investment. We can rearrange that to read investment is equal to output minus consumption, or investment is equal to savings. Hence, along this line, investment I must equal savings S. Hence, the IS curve. So, let's review some of the key ideas in this video. The IS curve summarizes the equilibrium output gap and interest rate in the goods and services market. It slopes negatively downward in interest rate and output gap space. It shifts to the right when demand increases on an autonomous basis, and it shifts to the left when demand decreases on an autonomous basis. Now, if you're interested in putting some of these ideas into some numbers, you might want to have a look at chapter 7, 8, and especially 12 in the book. And that's it.